Hello everybody, we continue to learn the analysis module of the continuous system as domain. Hello students, we will teach 4.2 below. Convergence domain of Laplace transformation. First, look at the definition of convergence domain. Convergence domain is the S region that makes Fs exist. That is, when the function Fs takes a finite value, the range of values taken by complex variables S on the complex plane. If function Fs exists, causal function Ft must meet two conditions. First, in the finite interval t, a is minor than t minor than b is integrable. That is, Ft is a finite value. Second, for certain delta 0, varies when the delta is greater than the delta 0, Ft multiplied by e to the power of negative delta t. The limit is equal to 0 when t tends to infinity, meeting absolute product conditions. When we put the delta greater than the delta 0, satisfy Ft multiplied by e to the power of negative delta t. When the limit is equal to 0, when t tends to infinity, signals are called exponential level signals. That is, the exponential order signal Ft can increase with the increase of Ft, as long as it grows lower than some exponential growth functions, such as n to the power of t. Let's study the convergence domain of the Laplace transformation by two examples. Example 1. Set causal signal f1t equals to e to the power of alpha t. That is, when t is less than 0, t is equal to 0. When t is greater than 0, it equals to e to the power of alpha t. Finding its Laplace transformation. Because it's a Laplace transformation for causal functions, the formula can be transformed according to the unilateral Laplace transformation. Fs equals 0, negative to infinity, s equals to delta plus j omega. We can get Fs equal to as shown below and multiply e to the power of negative j omega. Let's talk about it now. First, when delta is greater than alpha, e to the power of negative delta minus alpha is equal to negative infinity for e tends to 0. Then e to the power of negative j minus j omega t is an indeterminate number of finite values. So then Fs equal to s negative 1 over alpha. Fs is an indeterminate value when delta equals alpha. T tends to be negative infinity when delta is minor than alpha. Tending to infinity, e to the power of negative j omega t is the number of finite values. So Fs is determined. So Fs exists only if delta is greater than alpha. The convergence domain of the Laplace transformation of the causal signal Ft is delta is greater than alpha. Let's take a look at example 2. Send anti-causal signal f2t equal to as shown in the formula. That is, when t is minor than 0, its value is beta t. When t is greater than 0, it's 0. Solve its Laplace transformation according to the Laplace transformation formula. Fs is equal to 1 over delta to the power of negative s. The limit of t when t tends to infinity, t multiplied e to the power of negative j omega t. So when the t tends to infinity, when delta is minor than beta, e to the power of beta minus delta multiplied t. Negative infinity for e tends to 0, and e to the power of negative j omega t is an indeterminate number of finite values. So fs is then equal to 1 over s minus beta. Fs is an indeterminate value when delta equals beta. T tends to infinity when delta is greater than beta. When the negative is infinite, infinity for e tends to infinity. E to the power of negative j omega t is the number of uncertainties of the finite value. So Fs is uncertain. Therefore, Fs exists only when the beta is available. Therefore, the convergence domain of the Fs Laplace transformation is delta is minor than beta. Example 3. Set ft equals e to the power of beta t when t is minor than 0. Is at the time if t greater than 0 is e to the power of alpha t. Is a bilateral function. Solve its bilateral Laplace transformation. The sum of the two examples we've talked about earlier, that is ft equals f1t plus f2t. Then its Laplace transformation is also f1t and f2t, the sum of the Laplace transformations respectively, that is fs equals f1s plus f2s. The convergence domain of f1s is delta greater than alpha. The convergence domain of f2s is alpha minor than beta. So the convergence domain of fs is alpha minor than delta minor than beta. Between beta and alpha, when beta greater than alpha, image function of ft exists in the region. When beta minor or equal alpha, Fs has no common convergence domain in F2s, so Fs does not exist. Bilateral Laplace transformation facilitates analysis of bilateral signals, but its convergence conditions are more demanding. This also limits its application. Okay, that's all. Thank you.